Okay, so you guys out there in Zoom will see what I've posted on the screen. Test 3 will be a take-home test, and that will be based on chapters 5 and also 5 and 6. All right, those two chapters. Let me make a note of that here. And the final exam, and that will be, let me see here. That will be due on Wednesday. All right. April 29th. All right. I've already created a Dropbox for it, so make sure that you submit test number 3 there. And then as far as the final is concerned, according to the final exam schedule that is set by the college, for us, the final exam will be on the 4th of May, which is next week, Monday. And that exam will be comprehensive. So we'll be meeting here at the same time, 8 o'clock. And the exam will be for 2 hours, 8 to 10. I'm going to try to make it a question per chapter, all right? So make sure that, of course, you review everything, all your assignments, your tests, all that good stuff. And I'm going to make sure that I post the answer keys for the assignments as soon as possible, all right? So that's basically it as far as announcements are concerned. Now, if I can only get this desktop. Sorry.
I remember last semester you added the curve to the final. Are you still doing that this semester too? Or no?
Well, typically what I would do is add a curve to the total.
Yeah.
Right.
Yes, I'm sorry, that's what I meant.
Yeah, I'll add a curve to the total so that the person who gets the highest, let's say that is 90%, and I'll just bump everybody's total
10
by
points.
10 percentage points. Yeah. Okay, so for you guys here in the classroom, this is the issue. Whenever I try to open any one of these, it doesn't matter which one, it wouldn't open. I get this down here, but I don't know what's going on. Anyway, how am I gonna do this? So last time we were here, we were in the midst of doing assignment number 7. And I think we stopped at question number 2. So now we're going to move on to question number 3. So let me again. Okay, let me see if I can wing it somehow. So in question number 3, they're asking for you to calculate the standard EMF, delta G standard, and the K for the following reaction. And they gave you the equation. And the first thing we'll be able to do, scroll down to that question. Okay, so okay, so you're asked to find the standard EMF, delta G standard, and K. All right. So the first question is to find the standard EMF. So what we'd have to do is go to the tables. Remember, I gave you, or I showed you the tables with the standard EMF of certain, a lot of actually redox, or I should say reduction half reactions. All right. So let me do this for the students out there in Zoom. So what I would do is go to the tables and I would look up the equations that would be involved in this full reaction right here. So one equation that I would see when consulting a table, I'm going to write down here, and I'm going to do the same thing for you guys here in the classroom. Mercury 2 plus. And when I look up the value for the EMF, that will be equal to 0.92 volts. And then in the case of the reduction of gold, plus 3 electrons to form gold itself, and the EMF of that is 1.40 volts. Okay, so for you guys here, it would be 2 Mercury 2 plus 3 electrons to form Mercury 2 plus. And when I look up the EMF value, this is equal to 0.92 volts. So that would be gotten from the table, right? And then Au3 plus 3 electrons to give Au. And when I look up the standard EMF value for that, that is equal to 1.40 volts, all right? So that's the first thing I would do in order to solve this problem. And then now I need to identify what is the anode and what is the cathode. The cathode is where reduction will take place. So which one is more likely to undergo reduction? The one with the higher cell potential. So therefore, the gold, the reduction of the gold, that would play the role of the cathode. And the other one would be playing the role of the anode, all right? So this would be the cathode, half reaction, and this would be the anode, all right? So, if you remember, we said that the EMF of the reaction, the standard EMF of the reaction, would be equal to the standard EMF of the cathode minus the standard EMF of the anode, ODE. So therefore, that would be 1.40 volts minus 0.92 volts, right? So here, so the standard EMF of the cell is equal to the standard EMF of the cathode minus that of the anode, which would be 1.40 volts minus 0.92 volts. And according to my calculation, that works out to be 0.48 volts.
I said, I think gold one the cathode.
Because it has a higher EMF value. Okay, let me explain. Okay, let me write this down first for these guys out there. 0.48 volt. So basically, because the gold has a higher cell potential, associated with it. What that means is that between these two half reactions, this one would more likely occur because the higher the EMF value for that half reaction, the more likely that reaction will occur, which means that the other reaction would be occurring in the opposite direction.
Cathode is where the reduction occurs.
Cathode, right. And that's another thing you need to remember. Reduction takes place at the cathode and oxidation takes place at the anode. That's how I remember it. I don't know if that helped, right? Reduction, cathode, oxidation, anode, all right? Okay, so that's the EMF value, 0.48 volts. So that answers the first part of the question. The next part of the question is asking for you to calculate delta G. So let me erase this here. In fact, let me just clear this here. So there's a formula which we encountered before. Delta G standard is equal to minus NFE standard. All right? Right on the board here. Delta G standard is equal to minus NFE standard, right? Now, N, remember, is the number of electrons that is transferred in the redox reaction. So what is that number? Well, based on the two half reactions, in fact, let me rewrite this for the benefit of those students out there in Zoom. I'm just rewriting the half reactions here to give 2 mercury, 2 plus. And then for the gold, it's Au3 plus 3 electrons to give Au. And this value was 0.92 volts. And the EMF value for this is 1.40 volts. Okay, so basically, in order to write down the net equation, we'd have to basically do a couple of things. We would have to switch this equation around and multiply by 2, and this we would have to multiply by 3. And the reason why we multiply, we have to switch this around. Or I misspoke. We have to switch this around and multiply this by 3 and this by 2. So I just told you something incorrect. You guys out there in Zoom, let me correct that right now. We'd have to switch this equation around and multiply this equation by 3 and that equation by 2. So the reason why we multiply this by 3, this by 2, is because 3 times 2 gives you 6 electrons here. 2 times 3, 6 electrons. Remember, in every redox reaction, the number of electrons lost and gained would be the same, right? So the N in this equation, which I have here, would be equal to 6, all right? So delta G standard would be equal to minus 6 times Faraday's constant, which is 96500 coulombs, times the EMF of the reaction, which we calculated to be equal to 0.48 volts. All right, so minus 6 times 96500 coulombs. Remember now, this is Faraday's constant, F, times 0.48 volts. And when I worked that out, I got minus 2.78 times 10 to the 5. Minus 2.78 times 10 to the 5 joules. Now, here's the thing. The equation that you were originally given is where the mercury 2 plus is on this side and the silver is on the left side. What I suggested is that we switch this around to get the EMF of the cell, right? But so basically what I would have to do is basically for, and I think I made a mistake here, for, let me see here.
I thought Faraday's constant was coulombs per mole. Is it just coulombs?
Yeah, it's coulombs per mole, but because you have 6, you could say 6 moles here.
Okay.
And mole here,
Yeah.
right. I just realized something. You know what? Let me try this again. I'm so sick and tired of going back and forth. Yes, hi, this is Pete Nicely. I'm in room 114. I'm having an issue with the desktop here. Whenever I try to click on the icon to get the browser opening up, it doesn't, it just remains stuck. No, just try just to get the browser open. I'm trying to use Chrome. And even I even tried Explorer, that didn't work either. Oh, okay. Mhm. Uh, you're talking about the panel here with the different oh, you mean wait, what TV? Oh, oh, well, the TV is not on, so I don't know what's going on. Yeah. Well, okay, I think I'm straight from here. All right, thank you. All right, bye. All right. Okay, so but the same thing is happening there again with this. Oh gosh, I thought this was about to just start working. Sorry, folks, I don't know what to do now. It's the same thing that's happening when I try to open this up. Try this here. It's not opening up this, let's see. It's not, no.
There, it's not available.
All right, let me continue to struggle with this. Okay, so for you guys out there in Zoom, as I said before, where is my? As I said before, we have to multiply the first equation by 3. Everything is going wrong for me today. Okay, we have to multiply the first equation by 3 and the next equation by 2, right? So that the number of electrons are the same. And then to get the net equation, we'd have to add them. So when we add them, this is what we're going to end up with. You're going to end up with, so you're multiplying this by 3, so this will be 6 mercury 2 plus. Oh, as I said before, we have to switch this around. So let me do that now. The first equation. So that would be 6 mercury 2 down here, 2 plus up here, to give 6 mercury 2 plus 6 electrons. So for you guys here, what that means is that I'm switching this around to get 3 mercury 2 plus, mercury 2 plus, to give 6 mercury 2 plus 6 electrons. So I need to make a correction here. This would be 2 here, which would mean that this would be 3 here. And then for the gold equation, since that is higher in value, I'm going to leave that as it is. And we multiply that by 2, so you're going to end up with AU 3 plus 2 of these, plus 6 electrons to give 2 AU. And that's it. So multiplying this here by 2, you're going to get 2 AU 3 plus 6 electrons to give 2 AU. So when you add these two together, you're going to end up with, on the left, 2 plus to give, I'm sorry, plus 2 AU 3 plus to give 6 mercury 2 plus 2 AU. All right. Now, the EMF for that we calculated to be equal to 0.48 volts, right? But please note, let me do this here for you guys. So you're going to end up with 3 mercury 2 plus 2 AU 3 plus to give 6 mercury 2 plus 2 AU. And the EMF value for that we calculated to be equal to 0.48 volts. All right. Now, if you compare this equation to the first one, what do you notice? Compared to the first equation given in the question, which is this equation right here. What do you notice when you compare these two?
They not flipped.
Exactly. So what that means is that the EMF that the question is asking for is actually minus 0.48 volts, right? Because what we did here was for the spontaneous reaction, which would have a positive EMF value. But the equation that is given is that equation right here, which would be the non-spontaneous direction, and therefore the EMF of that would be negative. All right. And because of that, I have to make a change in calculating delta G. This here should be negative. Right? So let me write this out for you guys out there in Zoom. So delta G standard will be equal to minus 6 times 96500 coulombs times minus 0.48 volts.
Does the anode formula always get flipped?
Does it what?
Does the anode formula always get flipped?
For the spontaneous reaction. Because remember, for the spontaneous reaction, the EMF must always be positive. All right. So, and it depends on the sign too, actually. But yeah, you're right. Because again, reduction takes place at the cathode, oxidation takes place at the anode.
That's
Right.
why you subtract it, because then when it's like I think the other one was like negative 0.04, and then it's like minus a negative, which would cancel out.
Exactly.
If you're trying to find K, wouldn't it also, if you found the K for the first equation, couldn't you just do the like 1 over K to find the next one?
That could work too. Or you could use the equation, which is what I did. I used the equation ln K. But before I do that, let me just write down the answer here. So the answer here is going to be 2.78 times 10 to the 5 joules. So,
So what part on the equation?
oh, that's the second. So this should be positive, not negative, yeah.
Okay. I see.
Yeah. Okay, so that answers the delta G part. And then now to get the K part, we're going to use, now for you guys out there, I'm going to clear this here. To get the K, I'm going to use the equation which you are introduced to, ln K is equal to minus delta G standard over RT. And that means that delta G standard we calculated already to be equal to 2.78 times 10 to the 5. And in actual fact, the unit should be joules per mole. divided by R, which is 8.31 joules per mole Kelvin, times the temperature in Kelvin, which is 298 Kelvin, because these are standard conditions, so 25 degrees, which is 298 Kelvin. And when I did that calculation, I got minus 112, and that would be equal to ln K. So let me do this now for you guys here. So ln K would be equal to minus delta G standard over RT, which would be equal to minus 2.78 times 10 to the 5 joules per mole, divided by R, which is 8.31 joules per mole Kelvin, times 298 Kelvin. And when I work this out, I got minus 112. All right? So that means to solve for K, K would be equal to e to the minus 112. Up here. K is equal to e to the minus 112. And when I did that, I got a value of 1.82 times 10 to the minus 49. So here it's 1.82 times 10 to the minus 49.
If I just put joules per mole, like, that we put the delta G.
Yeah, delta G standard should actually be joules per mole, which means that this should be joules per mole here. I'm looking at the sig figs of this thing here. The thing about this here is that there are no decimal places in the 112. And you can't express that as 0 sig figs. I'm just going to leave that answer as it is. 1.8 2 times 10 to the minus 49. All right, so that's basically how that is done. All right.
I have a question.
Oh, yeah.
So when I put e to the negative 112 just in my calculator, I'm getting 2.28 times 10 to the negative 49. Do you know why that would be?
Let me see. Let me see. So 112, I'm
Or
going to try and
2.29.
Yeah, I got this.
Oh, it should be 2.29. Yeah, so let me correct that. So this here, I don't know where I got this number from. So let me correct that. So this should be 2.29 times 10 to the minus 49. So
You just use 8.31 instead of 8.314, just because.
yeah, yeah, usually I just run it off to 3 sig figs. So this should be 2.29. Yeah, the actual value of R is a long string of digits. So I just usually round it off to 3 sig figs. Yeah.
So when I also did the calculation for ln K, I got negative 115. I could do it.
All right, hold on. Let me do it. Let me do that. So 2.78 times 10 to the 5 divided by 8.31 times 298. I got 112.
I could do it again.
Yeah.
Wait, so the final answer is 2.2.
2.89. You mean for K?
Yeah.
Yeah, 2.89 times 10 to the minus 49. Which would be e to the minus 112.
2.29.
I'm sorry?
Yeah.
Oh,
2.29.
0.29. I'm sorry.
Yeah.
Yeah, 0.29, what he said.
Wait, why is it? Because isn't there a rule with sig figs where like?
Yeah, that's what I was thinking.
If it's,
I was trying to make, well, let me do this first. So,
you keep it even if there's a 5, right?
hold on. 2.29, I'm sorry.
Wait.
No, here's the thing, which is kind of weird about this, is that this number here has 0 decimal places,
Okay,
right?
Yeah.
If you remember when you're finding the log of a number, whatever the number of sig figs here, the number of decimal places will be the same. But I don't know how to express this as 0 as a figure or a number which has 0 sig figs.
okay,
So that's why I'm just leaving it like that. So,
okay.
You could
Yeah.
just do like 2 times 10 to the negative 49 or,
but that would be 1 sig fig.
oh.
You see what I'm
okay.
saying?
Yeah.
That would be one, right?
Yeah.
If you roll this off to 2, that's 1 sig fig, which means that if you were to do the reverse, that should be 1 decimal place.
I was wondering, cause like, I thought there was a rule rounding, like, since it's 2.285, that you keep it even instead of rounding up. Like, I thought that was a sig fig rule.
No, I don't know that rule. Not sure about that rule. All right. So that's basically how that is done. All right, the next question. Let me clear this here.
Is that not the, is that not the last?
Hmm?
Isn't that the last question?
Yeah.
Oh, you know what? I forgot, I should have, hold on, let me clear this first. I forgot that I should have posted an addendum. Let me see here. Here it is.
The official E that we found was negative 0.48 or.
The E for the, in answer to the question, yeah, it will be minus 0.48 because this is 0.48 and this is the reverse of that.
Yeah.
Right.
Oh, okay, I see.
You see what I'm saying?
Yeah.
So the answer for this one would be minus 0.48.
Okay,
We do this, I went through all this to find out the equation that is spontaneous. Okay, now, unfortunately, again, because of this whole, let me see here. Things are just not working out for me today. Okay, let me try and call them again. Oh, okay. There's another an addendum that I should have included, which is dealing with the other part of electrochemistry, which is electrolysis. And unfortunately, I don't have any copies of it here. You guys out there in Zoom, you're looking at it right now because I've just opened it up. Let me see if it's published.
Would that be turned in with this assignment?
Yeah, all right, tell you what, this is what I'm gonna do. I'm gonna publish this. Well, it's already published, right? And I'm going to leave you guys to do it. Now, you might have some challenges, maybe. If you watch the videos, the video lectures, that should help. But what I'm going to do is I'm going to create a Dropbox for this assignment. So basically, what you have there, you're going to add that to the, or you're going to do this and attach it to that. And you're going to submit it in the assignment section. So this would be assignment number 7. And I'm going to let that be due. Today is the 27th. I'm going to let that be due on I'll give you until the 30th, which is Thursday. So let me do this here.
Are we gonna turn in assignment E before the final then?
Yeah, I'm coming to that. So this is available now. Okay, so that Dropbox will be available for you until the 30th. Now, you asked about assignment 8, which deals with nuclear chemistry. What I'm going to do is I'm going to publish that assignment as well. This particular chapter is not really that difficult. So I think you guys should be able to handle it. But of course, if you have any questions while you're doing it, please feel free. I'm going to make myself available during my office hours. So this is assignment number 8. Oh, it's already published. Right, so I already published it. Let me create a Dropbox for that as well. So that will be, let me see here. I'm going to let that be due on Friday. And again, if you have any questions, please feel free to contact me about that. Oh, wait a minute. I gave the wrong date here. Hold on. Yeah, hold on. Okay, that's correct. Okay, so that will be due on Friday, May 1st. All right. I apologize for the snafu with the desktop here. In the time that's remaining, if you have any questions you want to ask concerning, again, I'll try to do my best in terms of working without the desktop. Or if you guys out there in Zoom have any questions, let me make sure that I have everybody's attendance. Okay, okay, Lombardo is here. Mendez, Peltz, Ray, and Webster. Okay. So any questions? Any questions? I'll be in my office today from 2 to 5 if you have any questions while doing any of these. In fact, I'll be in my office today from 2 to 5, and then on Wednesday 2 to 5, Ocala here, 2 to 5 at the Citrus campus, but I can be online. Oh, somebody has a question. Okay, so somebody's asking if the final exam will have all the topics from assignments 1 through 8, and the answer is yes.
I have a question as well.
Oh, yes, sir.
So in our chemistry lab with Taylor, we had like gone over this last week a little bit, and we had to ask him some questions because we hadn't done it yet.
Gone over what exactly?
So the EMF values
Oh, okay,
for
okay,
things.
okay.
And he was saying you could basically just flip the sign of the cathode and add them together to get the EMF, which seems
That's
to
what,
work.
that's another way of doing it because, hold on, you said flip the side of the cathode?
It's just because you're grounding negative. That's why he explained it that way. Just to keep it always positive.
Oh, to keep the cathode positive?
Or keep the, like,
The final,
the final EMF.
right, exactly.
Yeah, you're just subtracting a negative.
Exactly. The way I like to look at it is that I just keep in mind that the cathode is where reduction takes place and the anode is where oxidation takes place. And since all the, I mean, if that works for you, that's fine. But the way I look at it, since the table that you'll have access to gives only reduction potentials, right? Where electrons are added to something to give you a product, right? That means that if you have two, like the two that we're dealing with right here, if you have two half equations, the one with the larger value is the one that's most likely to occur as written, right? So in this particular case, it was the gold, right? 1.40 volts, which means that the other half equation will be flipped, right? So the gold in this case, the gold electrode would be the cathode because that's where reduction is more likely to occur, which means that the other mercury electrode would be the anode because the reverse reaction, which would be the oxidation, will occur. So that's the way I think of it. Oxidation at the anode, reduction at the cathode. And then you can do a simple calculation also where E cathode minus E anode gives you the cell potential. I'm still trying to figure out. So you were saying that Taylor tells you what, that you flip.
So I'm not entirely sure. I might be getting that wrong. I'm just trying to figure out, okay, so like we got 0.48 volts. So just
Right.
because we flipped the mercury equation, we just make it negative.
Exactly. Exactly.
Okay.
And then and the reason why we flip that equation is because it's a redox reaction. If you have reduction taking place at the cathode, then oxidation taking place at the anode. And therefore you flip the mercury, in this case, the mercury reaction, so that it's representing an oxidation. And then you add them. Of course, you have to make sure that the number of electrons lost and gained would be the same, right? So in this case here, we had to multiply the 3 electrons by 2 and the 2 electrons by 3. But again, I think I stressed this the last time. If you multiply the equations by any number, the EMF values remain the same. They don't change, the standard EMF values, all right?
So for the reverse equation, it's still gonna be the positive volt.
Yeah.
Okay.
Okay, let me see here. Okay, any other questions? Any other questions? Please come and see me or call me, or we can set up a Zoom link if you can't make it to my office. If you have any questions, please, because I want to make sure that you guys do your best in terms of the assignment, and this would help you in the final exam, of course.
We really grab a copy for something like that without having to bring that.
Well, this here is actually the assignment for the nuclear. I was hoping that we'd get to it today, but we didn't, but you know.
Thank you.
In fact, here you go, sir.
I actually printed it out.
Oh, okay, all right.
Thank you, though.
Here you go, man.
Is this like similar to the lab that you had, the assignment with the lab? I don't remember if you did that,
Maybe there's some similarities.
because it was dealing with like.
Balancing nuclear equations.
Yeah, because
Right.
like what I have is when it comes down to proton, it like depends on where you look at it, but it always uses like helium with the 1 and then the 1 next to it.
No, helium doesn't have 1 and 1. Helium has 4 and 2. You're talking about the alpha particles.
Yeah.
Right.
That's what I meant. I'm so sorry. Yeah. Yeah.
Right.
All that.
Yeah, helium is alpha particles.
Why is it represented by helium?
Well, it's actually a helium nucleus. Right, helium, and you can tell by the atomic number. The atomic number is 2. Helium is the only element that has the atomic number 2. Now, the mass number may change depending on the isotope,
So is that like
But specifically, the alpha particle is the helium-4 nucleus.
Okay,
Yeah.
cause I was always wondering that, cause like I saw it and
Mhm.
I read it.
Yeah, but balancing nuclear equations is pretty simple. Basically, you have to make sure that the total sum of the atomic number is the same on both sides. And the same is true for the mass numbers, right? And then, like in the case of the first question in assignment 8, right? It has only one product, and that product should have the same atomic number, or the atomic number of that product would be the sum of the atomic numbers of all the nuclei on the left side of the equation. And the same should be true for the mass numbers as well.
So for that first question, would it be like 214 plus 4?
It would be, for the mass numbers, it would be 214 plus 2 times 4, because you see the 2 in front of the,
Yes.
right. So that's 218 and then 0, so that's 218, no, what am I saying? 214 plus 8, that's 222.
Yeah, so.
My
it'd
bad.
it'd either be D or D.
So the mass number is 222, and then for the atomic number, you'd have to add 84 plus 4, so that's 88, minus 2, because 2 times minus 1 gives you minus 2. So that's 84 plus 2, 86. I'm sorry, 84 plus 4, 88, minus 2, 86.
Okay,
So therefore, the answer would be D, which would be radon 222, 86. Or 222, 86, then Rn. So that's how you do that. You just add up the sum of the mass numbers. Both sides, it should be equal. And the same is true for the atomic numbers. Okay, any other questions? Any other questions? Yes, sir.
Find a,
So you attempted that one already?
yeah.
Oh, okay, cool.
So for question number 13, on assignment 8,
Mhm.
the particle emitted, it's like an electron, but. Yeah, that's.
13. Oh, okay, yeah.
Just wondering, what's the name of this?
Oh, that is called a positron.
Right.
Right, exactly. So in that case, the mass number will not change.
Oh, that doesn't change. the
No,
mass?
because the positron has 0 mass, right? So therefore, whatever the species that is produced, it would still have the same mass number.
Right.
37. Right.
Okay.
And then now, the atomic number will be, when you add it to plus 1 gives you 19. So that means that will be 18,
yeah.
Right.
right? So the
it's-
so the mass number is 37, the atomic number is 18. So therefore, the answer is C.
Right, that's what I wrote down, but I just want to make
Yeah,
sure.
yeah,
Thank you.
right, exactly. Right. So that's how you do that. The only thing I would say about these questions is that you have to be careful in terms of, adding, the mass numbers and atomic numbers. But once you get that straight, I mean,
How do you like, do you want us to show a work at common paper?
no, you don't have to show the work
So
for
I can
these.
just like, if I know it's like D, I can split D.
Exactly.
Okay.
Mhm.
I have a question about
Yes, sir.
the STEM club.
Oh, yeah.
The panel was pretty cool. I was wondering, like, what other kinds of activities do you guys normally do? in
Okay,
the STEM club?
so we didn't get to do much this semester. A lot of hiccups that took place, but basically, we typically go on field trips, for example. In fact, I'm thinking I'm going to call the lieutenant at Marion County Forensics, forgot his name. Anyway, to see if we can next semester, see if we can tour their facilities to see what it's like. And so, field trips is usually a part of our activities. More professionals coming in to talk to us. But I would say the most important thing I'd like to get the club members involved with is internships. I want
Right.
you guys, to do internships so that, you have that as a part of your, whenever you apply to grad schools and so on, they can see that, well, you have done some research and that, they typically, look favorably on students who have gone through that kind of experience. So
Okay.
those are the things, I would say, the 3 main things that the STEM club would engage in. I was thinking as a sort of fun activity, I was thinking of also the STEM Club hosting a, I don't know if it would be a panel discussion or debate on science and religion. I think that would be a bit of a fun activity to engage in. So those are the kind of things that we try to do. And if you guys have any other ideas as club members, you know, I have no problem with that. Hold on, somebody said something. This is a private question. Okay, I guess I should not be reading it out loud then. Who is this, by the way? Oh, Kylie, okay.
Do we just email you directly about joining the STEM club?
Okay, so email me, include your ID number. And what I'm gonna do is I'm going to add you to the STEM Club Canvas shell. That's where everything is, like our meetings, announcements, and all that good stuff. So if you do that, I'll just add you to the Canvas shell. And if I remember correctly, what happens next is that you're sent an invite and you have to respond to it in order to actually get into the Canvas shell itself.
Okay, sounds good.
All right.
Thank you.
Yeah, no problem. So do that as soon as possible.
Okay.
Okay. Okay. Thank you, Miss Chang. I'll definitely look into that. Okay. Any other questions? Any other?
It would be being graded.
I'm going to start grading it today. I don't know when, so maybe by tomorrow.
Oh,
Yeah, but
do you think like by the time that we take the final, all the other assignments would be graded?
that's a plan. Except in maybe assignment 8, in which case, as soon as
Will you like post the assignment?
I'm going to post the assignment key for assignment 8. In fact, I think I've already posted the assignment key for assignments 6 and 7. Let me just check and make sure.
Because I know you've done like pretty much all of them besides like the newest one.
Okay, let me see here. Okay, assignment 6 key and assignment 7 key has already been published. So you can have that to review. And then I'm going to post assignment 8 key on Friday. And you
To go over organic chemistry for this course?
I typically don't.
Is it just like because of like time wise or?
Yeah, the time constraints, especially what happened this semester with,
But like in general, we just usually to at least have some bit of that.
Yeah, so yeah, but not much. It's not like, it's just some introductory stuff. Like hydrocarbons and alkanes and alkenes and all that good stuff. Okay, any other questions? Or as they say in Spanish, preguntas?
That's free, we have to have it completed by Wednesday.
I thought I said Thursday. Hold on.
That's 3 days Wednesday.
Wednesday? Okay.
Assignment 7 is Thursday.
Oh, okay.
Something like that.
Hmm.
And then, so you said that like whatever the highest grade is, that minus 100 would be the curve, like the curve to the overall grade?
Yeah,
Okay, so like. It's like, so if you have like an 80 class, and let's say the highest grade in the final is a 90, that's plus 10 to the 80.
exactly.
Oh, wow.
So it all depends on who does
So are we
the
like,
best.
we're trying to like make sure that we like the highest person is like not, like, let's say we want it to be kind of like an 80 or something like that, is that what we're trying
You want
to?
to be like what?
Are we trying to get it to the point where like the highest grade in the final was like an 80, is that what the goal is pretty much?
No, I just want to basically, give everybody, a chance in terms of who gets the highest.
So the grade on the final, like, carries over to a curve on the grade for the entirety of the course.
Exactly, yeah. So
Okay.
I don't know if you're here when I was explaining it, but basically what I do this for all my courses. Whoever gets the highest in everything, add up all the averages, the tests and so on, then that person will be curved up to an A. So if somebody got a 90% after doing everything, right? I put it in the system and the person got 90%, then that person would automatically be bumped up to 100 and everybody will be bumped up accordingly.
So that's like every single assignment, like all the assignments put together, like whatever.
Everything, assignments, tests, final exam,
Oh, so it doesn't, it's not only the final, it's like
No.
final plus everything.
everything, right?
Oh,
So
so
if that person gets 90%, then I will curve everybody 10%. So
Okay.
that person will get 100 and everybody's average score.
See,
Yeah.
it's not only the final that.
No, not only final.
So if it was like a person's the highest grade in the class was like an 87.
If
Then it's
then
13 points.
13 right, I'd add 13 percentage points to everybody. So
You still drop the lowest test and everything.
and yes, I still drop the lowest test and I drop the lowest 3 assignments.
3 assignments.
Yeah.
too, as well.
The lowest test.
Right, so
Like
test
I
1,
said,
2, and 3. Exactly. So I drop the lowest test, I drop the lowest 3 assignments, and then I average everything, and then curve accordingly. If somebody gets like 87, as you said,
Yeah.
everybody gets a 13.
So if I have 100, plus 1, 2, can I just not take test 3?
You could do that, yeah, you could do that. You could do that, yeah, that is, yeah, because absent means 0, so, right.
I bet according to the Canvas, your syllabus says like if you don't attend a test, it's a 0 and then like it doesn't get dropped. Like
No, it dropped,
it still gets dropped and everything.
right, it dropped. If it's a 0, it gets dropped automatically. I mean, it can't get lower than a 0. You had a question? I saw your hand up. Oh, okay.
Also, if you went to the Stedford West Street thing,
That too.
20% gets added to the final.
What did I say?
You said if you attend in person, you get a 20%. If you attend online, it's a 10.
Okay, yeah, that too, yeah.
Like as in 20 points or 20%?
Percentage points. Percentage points.
So like if you got a 60, you get an 80. Okay. I don't know.
Yep.
And then how much is the final is 30 or 20%?
Final will be 30% of your total. The assignments is 20 and no, wait a minute.
Tests were 50, I don't know what the assignments in the.
Hold on. Yeah, the test is 50. Final exam is 30% and the assignments is 20%. Yeah.
Do you think you could open up the final assignment in Canvas so like we can like test grades and stuff?
I'm sorry, repeat that?
So like can you open the assignment on Canvas for the final so that we can like see what we need to get an
You
A?
mean like a review? You mean like
No.
a past test?
No, just like the actual like assignment where you can like test if you got like an 80, what would your grade be, so on and so forth. You know what I mean?
Like add it to the grade book so you can put like a what.
Oh, yeah.
So let me see here.
Cause you know, like you could do that for the previous test where you put like test 1 as like a.
So if I open this final. Okay,
But is it also possible that you could publish past test keys for the final too?
yeah, I could do that. Okay, I've opened up the final, what do you call it now? Let me see here, grades.
I guess like just put it in a grade book is what he was saying.
Yeah, I think I've done that just now. Okay, and then you were saying, past final exam?
Yeah, it'd be good just so.
Okay, let's see here, final,
That's
that would be in the past test. answer keys. Let me see here.
Are you also ever gonna like, cause you know how there was the for assignment 2, you had the second part where it was like additional kinetic equations? I don't know if you remember that, but you made us like submit that and it was never graded, at least for me was. It was like, I probably have the assignment 2 with me. It was like.
That I don't
I
recall.
think you just included
Mine
it in
didn't
the,
get graded either.
What's that?
Mine didn't get graded either, the
I think
additional
you included
kinetic
it.
question.
you included it in the grade for just that assignment, like for that week. Like I think if it was like a.
Okay, so let me okay, so I'm going to open up a final exam from 2017 right now. Let me just take a quick look at it to see what is in it.
So is the final gonna be like questions that we actually have gone over, or would it? I get what you're saying, like questions that are like, that were covered at least in the assignments and tests,
Mhm.
okay.
Okay, so I'm looking at this past final. This should be a good, you know, preview, so to speak, or a good way of preparing for your final exam. Please ignore the part in the first page of this document which says answer any 5 questions, because you're going to answer all questions in the actual test. Okay, 2 hours.
And then how many questions are on there?
1 question per chapter, so that's what?
Like 8, so there'd be 8 questions?
Yeah,
Okay,
so 1 question per chapter. That would be it.
So wait, it's a 2-hour test during our class period next week?
Right,
we
exactly.
come into this classroom.
This classroom, right.
Okay,
It-
so
Yeah,
I'll have
forget
to
the
like
testing
let
center.
work know that it'll probably be a little later.
What's that?
So it won't be till 9:15, it'll be till 10.
No, on to 10 o'clock, yeah.
Okay.
Yep.
And then would you have like the physical copies of all like the KC, KP con?
Oh, yes, I will be providing all the tables that you're gonna need. Including the one for the electrode potentials. The dissociation constants. What else? There was something else. Oh, and the thermodynamic, like delta G and so on.
Like with all the intro.
Intro, right. So all of that will be provided too, in addition to the regular, periodic table conversion factors and so on. So all of those will be provided.
And then what time do you think like the final, like our final grade will be posted by?
Good question. I have so much on my plate, I can't even.
Cause you have to have like, it's like the 15th, I think is like your last day, you have to post it.
The deadline for posting the grades would be, hold on 1 minute. I think it's the 15th, but let me just make sure I'm telling you the right thing.
I know you dropped the last 3 assignments even.
The lowest to the assignment.
Yeah, I'm sorry.
Okay, this thing is taking a long time to.
If like the person for the curve, like let's just say like a 100, like I know it's pretty unlikely, but like let's just say there is that person who's just that good and they have a 100. What do you do with that curve then? Is it just a 0 then?
Exactly.
Okay,
But I've never had that before, so.
What's been your lowest curve ever?
Ooh, I think it was 5.something%. Or
that's still pretty good though, like honestly. Cause I can get from like a B to C or I'm sorry, from C to B or.
I can't seem to bring up the.
Cause I know last semester it was 13 with extra points.
So
Nine.